Welcome dear students. Today we are going to discuss on our new unit of advanced materials, that is composite materials. So after studying different units of this subject, you are now familiar with different advanced materials, their properties, applications, and why these advanced materials are superior than our conventional materials, or their different limitations of conventional materials, so that we have to think on this new material. Now this unit, composite material, it is slightly different the aspect of studying this unit. You will come to know what exactly is composite material and its applications and the properties of composite material. We will begin with basics of composite material. What exactly we mean by composite material? So composite is a combination of two or more chemically distinct and insoluble phases. Composite constituents, materials or phases must be significantly different properties from its to combine them. Thus, metals or plastics are not considered as a composite, although they have lots of fillers and impurities in them. Properties and performance of composites are far superior than that of its constituents. Composites consist of one or more discontinuous phases. We call them as a reinforcement, which is embedded in the continuous phase. We call it as a matrix, and based on this, the examples of composite material are cemented carbides. Now cemented carbides mean tungsten and tungsten carbide along with a cobalt as a binder is one of the example of composite material. Rubber mixed with carbon black. Now rubber along with carbon black is another example of composite. Then natural composites are also available. For example, wood is an example of natural composite, where you will find the reinforcement as well as the matrix in it. Now here in this photograph, you are observing wood or artificial wood, in which the figure A, laminar composites of layer of wood veneer is there, and in second figure fiberglass reinforced composite containing containing strong fiberglass along with a softened polymer matrix material. And in third figure, again a man-made composite material. It is a concrete particulates composite consisting of coarse sands or gravels in a cement matrix. Having a percentage composition of say 50-50. Then next classification of this composite material is based on the different criteria. So these different criteria of classification of this composite material includes composites are very strong and stiff. Strong and stiff, these two properties are exactly contradictory properties. You will find in composites are having lighter in weight, and the ratio of their strength to weight is also high. The stiffness to weight ratio is also several times greater than our conventional metals such as steel and aluminum. Other characteristics or features of these composites includes high specific strength, high specific stiffness, long fatigue life, then high creep resistance, low coefficient of thermal expansion, low density, low thermal conductivity, low wear resistance, better wear resistance, then improved corrosion resistance and better temperature dependent properties. So these properties makes composites as an attractive engineered material in the field of engineering and technology. Then these composites are having certain limitations also. So what are those limitations of composites? The disadvantage of or limitations includes properties of many important composites are anisotropic. That means they are only oriented along certain directions. They are not uniform in all directions. So properties differ depending upon the direction in which they are manufactured or measured. This may be advantage, or sometimes it may be considered as a disadvantage of composite also. Many of the polymers based composites are subject to attack by chemicals or solvents. So just by polymer themselves, they are susceptible to attack. So they deteriorate their properties, or there is drastic reduction in the properties when they came in attack with the chemicals or solvents. Then composite materials are greatly expensive. So cost is again considered as a limitation of use of composite. Then manufacturing method of shaping composite materials are often slow and costly. So manufacturing cost, energy required, setup required to make the useful component from composites are also costlier, and it makes limitations to the composite. But whatever it may be, these composites are nowadays plays an important role for special applications in different industries. So as I said that composite is made of two phases. Primary phase is a matrix material and secondary phase is a reinforcement material. So this composite matrix phase, what performance or what functions this matrix material does, that we'll see. So this matrix material provides bulk form. So it contributes a major portion of a composite. So product made of composite material is having major portion of composite matrix constituent. Then matrix holds embedded phase in place. That means it covers the entire reinforcement material, including all forces or the stresses acting on this composite material, and it divides that stress or force acting on the composite material to the reinforcement. When the load is applied, matrix shares the load with the secondary phase, that means a reinforcement phase, in some cases deforming so that the stress is essentially borne due to reinforcing agent. Now cement is the example. Suppose here ceramic up to 90% contain metallic matrix, and cemented carbide, it is a combination of tungsten, titanium and chromium carbides along with cobalt as a binding element. Then cutting tools, dies, indenters, they are made up of different composite materials, and these composite materials play a vital role in the industry for variety of applications. So next, how to classify the composites. So there are different methods of classifying the composites. So one of the criteria of classification of composite is a type of matrix material. So they are classified or named according to the matrix material. So polymer matrix material is the first class. Then second is the metal matrix composite. Third is a ceramics matrix composites. Fourth is a carbon-carbon composite. That means carbon material is a matrix, as well as the reinforcement form is also carbon material. So based on matrix material, composites are classified into four groups. Then second way of classifying the composite material is based on geometry of reinforcement. So how the geometry of reinforcement is? So particulate reinforced composite. So reinforcement form is a particulate. Then second is whisker or flex reinforced composites. Then flex or whiskers is another form of reinforcement material or reinforcement geometry. Then the third is a fiber reinforced composites. Now here form of reinforcement is a fiber. So these three categories are the types of composites based on their reinforcement geometry. Then another special you can say category is a hybrid form. Or hybrid means a composite laminate comprising of lamellae of two or more composite material system or combination of two or more different fibers such as glass fiber and carbon fiber together, or glass and carbon and aramid fibers together. So when the fiber material is of two constituents, then that composite is called as a hybrid composite. Now then this figure or this graph shows you the classification based on the matrix material. Now reinforcement is placed at the central, and metals, ceramics, then carbon and polymers. These are the four basic matrix materials, and when they are combined with the reinforcement material, the new type or new class of composite material is formed. So metal matrix composites, ceramic matrix composite, carbon composites and polymer matrix composites. These are the four types of composite material based on their classification on matrix basis. Then polymer matrix composites are a prominent class of composites as compared to the other composite materials in commercial application. We will find wide variety of composites of polymer matrix composites. Then fiber materials such as boron fiber, graphite fiber or carbon fiber, they are reinforced into a polymer to form a polymer matrix composite. Most of the PMCs, that is polymer matrix composites, uses either a carbon graph or a graphite or aramid fiber, which are the main commercial fibers. Then in this category of polymer matrix composites, they are classified into again which polymer material is used, whether the polymer material is a thermoplastic type or a thermoset type. So normally thermoplastic material such as epoxy, and in case of thermoset, the other thermoset plastics are used as a matrix material to make the polymer matrix composites. And in case of metal matrix composites, material of matrix is a metal, but while selecting material for a matrix in metal matrix composites, attempt is made that metal should have lighter strength. So metal matrix composites are advanced class of structural material consisting of non-metallic reinforcement incorporated with a metallic matrix. Metallic reinforcement incorporated with a metallic matrix. And metal matrix composites are widely used in engineering applications where the operating temperatures lies between 250 to 750 degrees centigrade. Here normally a matrix material such as aluminium, titanium, copper, magnesium and some of the super alloys are also used as a matrix material for metal matrix composites. But the non-metallic reinforcements are of silicon carbide, boron, molybdenum, alumina is made in association with a matrix material to form the metal matrix composites. Then third important type is a ceramic matrix composite. Now these ceramic matrix composites are advantageous advanced class of structural material consisting of either metallic or non-metallic reinforcement incorporated with the ceramics as a matrix material. Now the ceramic matrix composites are widely used in engineering applications where the operating temperature lies between 800 degrees centigrade to 1650 degrees centigrade. So application working range or the operating range of this ceramic matrix composite is too high. And the next important class material is a carbon-carbon composite. We will see these carbon-carbon composites in a separate lecture, but up to this point, the different three classes of composite material or the general discussion about the composite material, you are well familiar with this new category of material and how this new category of material is different than the existing class of advanced material that is our objective of today's lecture. So we'll stop here.